All right, so yesterday we started looking at the Pythagorean theorem. Remember, we looked at it as a squared plus b squared is equal to c squared. And we saw that happens when we have a right triangle. So here, for 17 through 20, I noticed that my triangles have a 90-degree angle. So yesterday we found out how to find out whether a triangle is a right triangle, an obtuse triangle, or an acute triangle. Now we're gonna be just looking at here, and we notice that it has a 90 degrees. Based on what we did yesterday, we remember that when they're a right triangle, we have the formula a squared plus b squared is equal to c squared. So let me just write that thing down. A squared plus b squared is equal to c squared. Now c is basically the biggest side. Okay, which one is a, which one is b, it doesn't matter. As long as c is the hypotenuse and c is the biggest side, which is the side farthest away from the 90 degrees. So what I'm going to do, let me square all of my sides. Let me square all of the sides. When it comes to x squared is just x squared. Square root of 6 all squared. If I remember square root of 6 all squared, I remember yesterday that I said square roots and square exponents, they undo each other. Okay, yes, I got the formulas here in the chat, yeah. So square root and the square exponents, they undo each other. So square root of 6 all squared is just 6. And then 4 squared is 16. Notice I squared every side. The hypotenuse, I said, is the side farthest away from the 90 degrees. So it is this side. That's the side that is going to be C. So let me write this as x squared plus 6 is equal to 16. I'm not going to square them again. I already did. Now my question here says find the missing side of each triangle. So I want x by itself. So the plus 6, let me move it to the other side as a minus 6. So that gives me that x squared is equal to 10. So that means that x is the square root of 10. If we can simplify the radical, if we can simplify the square root, by all means do so. In this case, we cannot. So my answer is square root of 10. So a reminder, how are we going to type square root of 10? On our homework, we're going to go SQRT for square root. And then inside parentheses, we're going to write 810. So square root of 10. Now let's take a look at question number 18. Let me square each of my sides.
I have a question.
Yes.
For the square root 10, do we have to put it in parentheses or else it'll mark it wrong, right?
It will mark it wrong, yes.
Oh, okay.
Now looking at number 18. Let me square each of my sides. X squared is just x squared. Square root of 6 all squared is just 6. Square root of 7 all squared is just 7. When we squared a radical, when we square a square root, we just get the number on the inside. So I squared each of my sides. The hypotenuse, the side that is farthest away from the 90 degrees, in this case, it's x. So I'm just going to go 7 plus 6 is equal to x. That means that, x squared, 7 plus 6 is equal to x squared. So that means that 13 is equal to x squared. Let me do the square root on each side. So I get the square root of 13 is equal to x. So there, square root of 13, I cannot simplify. If we were just writing it, we had a piece of paper, we were writing it, square root of 13. Because we're typing it, squared root of 13 is SQRT, and then the 13 inside parentheses. And yeah, we do have to include the parentheses. Notice how x is not always on the left side of the equal sign. Sometimes it's on the left, like in question number 17. Sometimes it's on the right side of the equal sign, like in question number 18. The number that I have on the right side by itself is the biggest side, is the hypotenuse. So looking at number 19, let me square each of my sides. x squared, 81, right? Because 9 squared, 9 times 9. And then 16, I'm thinking 16 times 16, that gives me 256. The side that is farthest away from the hypotenuse, the side that is farthest away from the 90 degrees, which is the hypotenuse, is this side. So that's my C. That's the one that I'm going to have by itself on the right side of the equal sign. So I'm just going to write x squared plus 81 is equal to 256. Again, I'm not going to square them because I just did. I want the x squared by itself. So the plus 81, let me move it to the other side as a minus 81. So I get x squared equals 256 minus 81 gives me 175. So that means that x is the square root of 175. Now we can simplify the square root. By all means, do so. Now this one we can. The previous two we could not, but this one we can. And what I mean we can is I'm going to break this down into two square roots. I'm going to think of two numbers that multiplied are equal to 175, but one of them has to be a perfect square. And the numbers I'm thinking are 25 times 7. The square root of 25 is a perfect square. So because I'm thinking two numbers that multiplied are equal to 175. One of them has to be a perfect square because the square root of 25 is 5. So my answer in here will be 5 square root of 7. If I can simplify more, by all means, do so. In this case, we cannot. The way I'm going to type this will be 5 square root of 7. So simplify your square root if possible. All right, lastly, let's take a look at number 20. Let me square all my sides. Square root of 11 is 11. Square root of, x squared is just x squared. And square root of 13 all squared is just 13. Squaring a radical is not too difficult. The biggest side is, this case is x squared. So I'm just going to go 11 plus 13 is equal to x squared. I know 11 plus 13 is 24. So 24 is equal to x squared. I have a question here. Do you get marked wrong if it is not simplified? Yes, because in the instructions, I'll come back to finish number 20. On the instruction, it says, leave your answers in simplest radical form. So you got to simplify. All right, looking at number 20, coming back to number 20. So I have the 24 is equal to x squared. So that means the square root of 24 is equal to square root of x squared. Remember, the square root and the square cancel each other out. So I have that square root of 24 is equal to x. And again, I have to simplify if possible. Now this one, square root of 24, I can. So let me break this into two square roots, thinking two numbers that multiply are equal to 24, but one of them has to be a perfect square. So I'm going to think 4 times 6. The square root of 4 is a perfect square. Right? Square root of 4 is actually 2, so it becomes a whole number. So my answer is 2 radical 6. The way I'm going to type this in, I'm going to go 2 square root of 6.
I have a question.
Yes.
Is there a space between the square root and the parentheses or no?
No, it's all together. No spaces.
Okay.
Thanks for asking that one. That's a good question. No parentheses. No spaces. All together. So that's using the Pythagorean Theorem. That's using it because I have a 90-degree angle. And in keeping that idea, right, Pythagorean Theorem, that a squared plus b squared is equal to c squared, we're going to move into question number 21. And here it's asking, state if each triangle is a right triangle. So I have the measurements of all three sides. But what it looks like a 90-degree angle, I'm going to put a question mark. I don't know if it is, right? It's asking Is it or is it not? I know for a right triangle, I know a squared plus b squared is equal to c squared. So I'm going to see if it is a right triangle. My answer here will be either a yes or a no, because it's asking, state if each triangle is a right triangle. So again, I'm looking for like a yes or no type of answer. Let me square each of my sides. The square root of 17 all squared, it's 17. The square root of 151 all squared is 151. Now 13 all squared, now that one I'm thinking 13 times 13 is 169. The biggest side is 169. So now here, let me write this as 17 plus 151. I'm going to put equals with a question mark on top. Equals 169. The question mark because I don't know if it is equal to. Once again, I'm checking if it is equal to or not. 151 plus 17, I know that's 168. So 168, 169. Okay, so they're not equal to. Therefore, my answer will be no. If they were equal to, then I would say yes. Because they're not, then I'm going to say no. In our English classes, we learned that when we type in a word, make sure you capitalize the first letter, right? They call it sentences when you write words and you capitalize the first letter. So make sure you capitalize the first letter. In this case, the N.
I have a question.
Yes.
It's not related to what we're doing right now, but it was from yesterday. It was on the simplifying questions where we were given like a fraction of two radicals, and when we get it to like the simplest radical form, say we got like square root 3/5, would we put the 3/5 in parentheses? Or just
When we do radicals yesterday, we mentioned yesterday that make sure there are no square roots at the bottom. They cannot be square roots at the bottom. That's one thing we have to cancel out. Obviously, the whole numbers, simplify your whole numbers, and the radical on the top, if you still have a square root on the top, simplify it. Let me finish today's lecture and then I can go back to yesterday's, okay? Okay. Now looking at number 22. Again, let me square everything. 9 squared is 81. 6 squared is 36. Now 3 square root of 5. If it was just the 3, just the whole number, 3 squared will be 9. If it was just the square root of 5 all squared is 5. Because it's both of them, combined is 45. Right? 9 times 5. Notice how I squared the whole number. I squared the square root, and then I multiply them both. All right, so we can tell the biggest side is 81. So what I'm asking here is 36 plus 45. Is it equal to, I'm going to put a question mark, is it equal to 81? Now 36 plus 45, right? We know how to add. 36 plus 45 is 81. So 81, it is equal to 81. So because I got it equal to, my answer will be yes. Capitalize the Y. Again, all I'm asking is a squared plus b squared equal to c squared? That's how I'm asking, is it a right triangle? Now let's take a look at number 23. Still the same questions, right? I'm asking, is it a right triangle? Is a squared plus b squared equal to c squared? Let me square all of my sides. 11 squared is 121. 8 squared is 64, right? 8 times 8. And then I, again, on the one that has a whole number and a square root, if it was just the 2, 2 squared is 4. If it was just the square root of 65 all squared is 65. Because it is both 4 times 65, use a calculator if you need to, 4 times 65 is 260. I can tell the big side is 260. So let me go 121 plus 64, because I'm adding the two smaller sides. Is it equal to, let me put a question mark, is it equal to 260? 121 plus 64, that's 185. Now 185, it is not equal to 260. So because they're not equal, then I'm gonna say, no, this is not a right triangle. All right, let's do one more. 11 squared, that's 121. Remember, I'm squaring each of my sides, so there's another 11 squared. Now here, 11 square root of 2. If it was just 11, 11 squared is 121. If it was just the square root of 2 squared is just 2. Now, because it is both, 121 times 2 is 242. We can tell the big side is 242. So let me add the two smaller sides. 121 plus 121 equals to, I'm going to put a question mark. Is it equal to 242? Now I know 121 plus 121 is 242. Now these two are equal to, so because they are equal to, I'm going to say yes. Right? Again, my question is it a right triangle? Yes. So far, I think the work from today hasn't been that difficult. Now, the hard part are going to be 25 through 32, those 8 questions. We're going to call those special right triangles. It is a right triangle, right? One of my angles is 90 degrees. But on this one, on the first 4, we're called those the 45, 45, 90 triangle. And the others, we call it the 30, 60, 90. And that is in reference of the angles. Even though we don't see the 3 numbers of the triangles, we're going to say 45, 45, 90, because last semester we learned that the 3 angles of a triangle add up to 180. So even though we only see 2 angles, we can pretty much find out the 3rd angle. And I'm just going to say the angles here are going to be 45, 45, 90. But on this one, let me explain something instead. Let me break something down. There are going to be formulas, but let me break this down. Let me draw a 45, 45, 90 triangle. And again, that is in reference of the angles. Let's say that one of my sides, I'm going to use an example. Let's say that one of my sides was 7. Interesting part is because 2 angles are equal, 2 sides are going to be equal. And the 2 sides that are equal are actually the 2 that make the 90-degree angle. The 2 sides that meet at the 90-degree angle. So even though I'm only given a side, I can pretty much say I know the value of the other side. Now the hypotenuse, for right now, let me call it x. And I know Pythagorean theorem. I'm going to say, let me square each of my sides. This is 49. This is 49. And this is x squared. Let me see, this thing just moved for me. Right there. Let me put it back right there. So I squared each of my sides. And I know Pythagorean theorem. I have to add the 2 smaller sides. I have that 49 plus 49 is equal to x squared. I know 49 plus 49 is 98. 98 is equal to x squared. So that means that the square root of 98 is equal to x. Now we know how to simplify, right? We talked about yesterday how to simplify. We talked about it earlier. So I'm going to say, all right, let me break this, my square root of 98, let me break it into 2 square roots. And I'm thinking 2 square roots that equal 98, 2 numbers that are equal to 98, but one of them has to be a perfect squared. I'm going to go 49 times 2. I know the square root of 49 is 7. So 7 square root of 2 is equal to x. So now this side, we just found out this side is 7 square root of 2. We can always use Pythagorean theorem if you guys forget formulas. Always, or you can use Pythagorean theorem. However, there is a formula. The two sides that meet at the 90-degree angle are equal to each other. If I'm solving for the hypotenuse, the easy way how to do this is you're going to multiply it by the square root of 2. Notice I have 7 times square root of 2. I wrote 7 square root of 2. A whole number can be combined with a whole number, square root with the square root, but you cannot mix them. So notice that if you're getting the hypotenuse, I could have just said, oh, let's multiply by square root of 2. If you're going backwards, obviously divide. Having that said, let's come back to our notes. Let's come back here. Here it says find the missing side lengths. I'm asking you here to solve for both. In your homework and your quiz, I'm going to be specific. I'm only going to ask you for one side, but I'm going to ask you which side. I'm going to tell you which side. Right? I could say solve for A or solve for B. Right? I'm going to ask you for one specific side. For the notes purposes, I'm going to ask you for both for the notes. And make sure you leave your answers as radicals in simplest form. So it's the square roots, make sure you simplify. If I was asking to solve for B, I'm going to say B is 4. Because the two sides that make the 90-degree angle are equal to each other. If I was asking you to solve for A, I just learned the formula is if you're solving for the hypotenuse, you're going to multiply the side, which is 4, times the square root of 2. 4 square root of 2. Now, a whole number and a square root cannot be combined. So that's it, 4 square root of 2. If you were typing this, obviously for B, just type in a 4, right? It's easy to type a 4. If you're solving for A, the way we type this is 4 square root of 2. So remember, when you're getting the hypotenuse, you multiply by square root of 2. If you're going backwards, obviously divide. Looking at number, what was that again?
Is that only if both angles are 45 degrees?
Yes. This happens for the 45, 45, 90. So looking at number 26. If I was asking you to solve for n, you will say, oh, that's not bad. This is 5 square root of 2 over 2. Because the two sides that make the 90-degree angle, the two sides that meet at the 90-degree angle are equal to each other. So 5 square root of 2 over 2, right? Not too bad. I'll talk about how to type that in. But for right now, let me just work on how to solve them. Now, if I was asking you to solve for m, first, let me write down what we have. 5 square root of 2 over 2 times square root of 2. So, matter of fact, the times, let me put it in a fraction. Let me put it on top. When we have fractions and we're multiplying by something, that's something we put it on top. If I was dividing, I will put it at the bottom. But here I'm multiplying. The funny thing is that I have 5 times 2 over 2. Because remember, square root of 2 times square root of 2, when you square the radical, you basically just get the number in the inside. So I have 5 times 2 over 2. There's two ways I can do this. I can just say, all right, let me multiply the numbers on the top. So I get 10 over 2, but I know 10 over 2 is 5. So it's just 5. Another way you could have done it, you could have said, well, let me cancel the 2's and get the 5. That's another way. So if I'm asking you to solve for m, the number that you had, you will multiply it. Remember, you multiply to get the hypotenuse, you multiply by square root of 2. If I'm asking you to solve for m, you just type in a 5. If I'm asking you to solve for n, because there's a fraction, we're going to use the backslash for the fraction. Now here I have is the hypotenuse 5 square root of 2. Not quite. Not quite. We noticed it was actually 5. Now, n, the way I'm going to type this, let me type in what I have on the top of the fraction first. So 5 square root of 2. Right? Because I'm typing what I have on top of the fraction. For dividing by it, I'm going to use the backslash. And after the backslash, I'm going to write the number 2. I want to type the number 2. We're using the backslash every time we have a fraction. Anything before the backslash goes on top of the fraction. Anything after goes at the bottom. So 5 square root of 2 over 2. That's if I'm asking you to solve for n. If I'm asking you to solve for m, it's just 5. All right, let's take a look at a couple more examples. If I'm asking you to solve for b, you will say, well, that's 2. Right? Not too hard. If I'm asking you to solve for a, you will say 2 times the square root of 2. We cannot combine them. A whole number with the square root cannot be combined. So just 2 square root of 2. Now here I have a question. So if one side is, for example, 4, would n be 4 as well? Depend on, I don't know what n is. I don't know which picture you're looking at. But the two sides that make the 90-degree angle are equal. Probably you're looking at the homework. Okay. Now let's take a look at number 28. Now, I don't know any of the two sides that make the 90-degree angle, right? In this case, are x and y. I know those two are equal. If I was able to solve for one, obviously I have the other one. And I know that if I had y, for example, if I had y and I was getting to the hypotenuse, I will multiply by square root of 2. Now, if I'm going backwards, instead of multiplying, I will divide. And I have a question here in the homework, and yes, I will be specific. I'll be specific on which one I'm talking about, which letter. Solve for A, solve for B, solve for X, Y, any letter specifically. Now here, so again, if I'm solving the hypotenuse, multiplied. But because I'm going backwards, I will divide. So let me write the number that I have first. I'm going to solve for Y now. So I have the square root of 6 over 6. That's the number given. But I'm going to divide by square root of 2. So let me write my square root of 2 at the bottom. When I multiplied, I write it on the top. When I divide, I write it at the bottom. And again, we learned yesterday that we cannot have square roots at the bottom. So let me simplify this a little bit. The 6 on the front, on the outside, the whole number, there's a 6 at the bottom. Nothing I'm going to do. I'm just looking at the square roots. I'm hoping the bottom is a perfect square, so that cancels out. But if it is not, I take a look at my square roots. And I look at this as a fraction. So I'm gonna write square roots on top and the bottom, but then I see it as a fraction. 6 over 2 simplifies to 3 over 1. Now, the funny thing is that the square root of at the bottom is a perfect square now. Square root of 1 is 1. So I don't have any square roots anymore. So this is square root of 3 over 6. Notice I multiply my two numbers at the bottom. 6 times 1 is 6. So I have square root of 3 over 6. I cannot simplify anymore. I know I see a 3 and a 6, but the 3 is a square root. The 6 is a whole number. Whole numbers go with whole numbers, square roots with square roots, but don't mix them. So my answer for y is square root of 3 over 6. Now, if I was asking you to solve for x, obviously square root of 3 over 6, because I said those two are equal. Now, how am I going to type that? Square root of 3 over 6. Right? No square roots at the bottom. So the 45, 45, 90, a little challenging, but not that much. Just remember, if you're getting the hypotenuse, multiply by the square root of 2. If you're going backwards, divide by the square root of 2. The other special kind is the 30, 60, 90. All right, now for this one, let me explain. Let me go back to a simple whiteboard here. For this one, let me explain how this rule came up. First of all, let me draw a 60, 60, 60 triangle. We learned back in the days, we learned that the three angles of a triangle have to add up to 180. So 60, 60, 60 is a good rule. Now, because all my angles are equal, then I'm going to say all the sides are equal. Just to say, for example, just to use an example, let's say all my sides are 8, just to choose a number. So I'm just doing an example here. Let's say all my sides are 8. And then I decided that one of my angles I'm going to cut in half. Let's say the angle on the top. Boom, I cut it in half. So to create another triangle, the 60-degree angle on the top becomes 30 because I cut it in half. I still have a 60 degrees, and now I have a 90-degree angle. So there, I have a 30, 60, 90 triangle, which is what we're going to be dealing with. The interesting part is the side at the bottom, it is going to be 4 now. Because I cut the angle in half, I also cut the side in half. The whole side to begin with at the bottom was 8. So obviously it is 4. One thing I want to emphasize here. The small side is the one farthest away from the smallest angle, which is 30. The small side, to get to the hypotenuse, I will multiply by 2 now. Not square root of 2, 2. This is how the small side and the hypotenuse are connected. The small side is always half of the hypotenuse. So from 4 to get to 8, you multiply by 2. And if you're going backwards from 8 to 4, divide by 2. But now there's this other side. Let me call it x for right now. But then I remember square Pythagorean theorem. I can do Pythagorean theorem. 8 squared is 64. 4 squared is 16. And x squared is x squared. Notice I squared each of my sides. So then I'm going to write x squared plus 16 is equal to 64. I'm looking at Pythagorean theorem. Again, I'm going to base this on Pythagorean theorem to come out with the formulas. I want the plus 16 on the other side as a minus 16. So then I'm going to have that x squared is equal to, I know the 64 minus 16 is 48. So that means that x is the square root of 48. But I know how to simplify square roots. 48, let me think of that as 16 times 3. Because the square root of 16 is 4. So then I get that x is 4 square root of 3. So just to look at my red triangle, I had that the big side, the hypotenuse was 8. The small side was 4. And the other side is going to be 4 square root of 3. So very nice thing. There's a cool thing that I want us to point out here. From the small side to the hypotenuse, you multiply by 2. From the small side to this other side, you multiply by square root of 3. If you're going backwards, obviously divide. Having that said, let's come back to our notes here. Let me come back to our notes. Let me see, where are the notes? Okay, so let's take a look at number 29. I'm going to look at 29 through 32 now. All right, looking at number 29, I know not all the sides are equal. And I have the small side here. The small side is 2. And I know if I want to get the hypotenuse, which in this case is x, I multiply the small side by 2. So 2 times 2 is 4. So x is equal to 4. If I want to get wide, I multiply 2 times square root of 3. So 2 times square root of 3. And that's it. If I have the small side, notice I multiplied each time. If you're going backwards, obviously divide. Now the question is why 3? That's actually what we got on our formula. If you remembered, let me come back to our board here. That is what we got. And that we got that from Pythagorean theorem. So now coming back here, let's take a look. I want the small side because in this case is y. Because I know once I have the small side, to get to x, I multiply by 2, right? To get the hypotenuse. To get to the other side, I multiply by square root of 3. And again, the square root of 3 came from Pythagorean theorem. If I have the small side, I don't have the small side. I have the other side. So let me solve for y. Let me solve for y first. Okay, Mercedes, I got your message. Okay, now here, let me write the number because I'm solving for y. Let me write the number that I have, 5 square root of 3 over 2. That's the number given. And I know if I was starting from the small side, I will multiply by square root of 3. Because I'm going backwards, let me divide by square root of 3. And remember, division, I write them at the bottom. The nice thing is that my square roots cancel out. So y is 5 over 2. Leave it as a fraction. Don't write decimals. Leave it as a fraction, 5 over 2. Now that I have the small side, now that I have y, I can solve for x. All right, so I have 5 over 2 for the small side, 5 over 2, but I have to multiply this by 2. So I said multiply it in fractions, we write it at the top. Dividing, we write it at the bottom. Now here it is. Do you always multiply by square root or square root of 3? Multiply or divide when you're not getting the hypotenuse, you're getting the other side, yes. Multiply or divide by square root of 3. To get to the hypotenuse, multiply by 2. Now here, we saw this example earlier. I can just multiply my numbers on the top. So 10 over 2, which is better known as 5. Or I can just cancel out my 2's and gives me 5. Again, on the homework, I'm going to be specific. If I'm going to ask you solve for y, my answer will just be 5 over 2. If I ask you solve for x, it is just 5. You have to have the small side. If you don't have it, figure it out, like solve it. Looking at number 31, I have the small side. The small side is the one farthest away from the 30-degree angle. And I know that to get to x, to get to the hypotenuse, I have to multiply by 2. Let me write this thing down. So 2 square root of 2 times 2. That gives me 4 square root of 2. Notice I only combine whole numbers, right? Whole numbers with whole numbers and square roots with square roots. Don't mix them. 4 square root of 2, and then the way we type this is 4 square root of 2. If I'm asking you to solve for x, that's it. Now, if I'm asking you to solve for y, starting from the small side, like I said, that's the side you want to have. Starting from the small side, I have 2 square root of 2. In this case, I have to multiply it by square root of 3. So that gives me 2 square root of 6. Notice that whole numbers with whole numbers, square roots with square roots. Don't mix them. Square root of 6 cannot be simplified, so that's it. 2 square root of 6. Again, for the notes, I'm solving for both sides. The homework and the quiz, I'm going to be specific. Solve for x, or solve for y. Looking at number 32, I want the small side. That's the side that I want. Here it is. How did we get the 3 there? At 3, remember that came from Pythagorean theorem. The square root of 3 comes from Pythagorean theorem, right? I just did it in the notes. Okay, so here, again, I want the small side. From the small side, to the hypotenuse, I know I multiply by 2. And that's what I'm going to do as soon as I got the value of y. From the small side to this other side, I multiply by square root of 3. Now, because I'm going backwards, I'm going to divide. So I have 10 square root of 3. And because I'm going backwards, I'm solving for the small side. Let me divide by square root of 3. Again, if you're starting from the small side, you multiply. If you're getting the small side, you divide. The nice thing is that the square root of 3's cancel out. So my answer is just 10. If I'm asking you to solve for y, 10. If I'm asking you to solve for x, 20. Right? The small side times 2, 10 times 2, 20. You have to get the small side. All right, let me zoom out for what we did today so you guys can take a screenshot